So a little bit on the spectroscopy of these carboxylic acid derivatives. The carbonyls IR frequency is really the most useful type of spectroscopy to figure out whether it's one type of carboxylic acid derivative versus another. So take a look. Here's our regular old saturated ketone at 1715. Okay. The amide is the only one that's lower frequency, so 1650 or so to 1690. All the other ones are higher frequency, okay? And they sort of go up in order of reactivity. So the most reactive of them all, the acid chloride, has the highest frequency. And anhydride is very diagnostic because it has 2 carbonyl peaks. In any IR, the first thing you do is look at the carbonyl region. If you see 2 in the carbonyl region, that's very strong evidence that you have an anhydride, especially if one of them is very, very high frequency, up above 1800. Okay? Esters around 1735, so just a little bit higher frequency than the standard. Okay? Acid chlorides, if you have just one high frequency carbonyl, it's most likely an acid chloride. If we have a carbonyl, if we have any of these that are aromatic and conjugated, that will lower its frequency, right? So you have to be a little careful. You could have a saturated ketone that is conjugated and would be down here within the amide range. So look at your other evidence, look at your chemical formula or your mass spec evidence or something to look at what atoms are there. We talked about the mass spec evidence to see if there's a chloride or a chlorine present in the molecule, right? We talked about mass spec evidence for if there's a nitrogen in the molecule. You can use that to your advantage. I say don't memorize these specific values because, they're ranges anyway, but do know that the standard is 1715, that the more reactive ones are shifted up from there. Amides are shifted down. Look for 2 carbonyl peaks for an anhydride. In NMR, you can't really tell what the carboxylic acid derivative is, but if you have a formula, you can still figure out what the molecule is. One characteristic peak, if you have a singlet at 2, that's characteristic of an acetyl group, right? A CH3C double bond O attached to something else, okay? An H next to a carbonyl is right around 2. So acetone is a singlet right at 2. So any kind of acetyl carboxylic acid derivative will have one of those singlets. And this one has a characteristic ethyl frequency. This one right here is next to an electron withdrawing group. So CH to CH3, that could be an N or an O or a chlorine. For it to be functionalized with the rest of this molecule, it has to be at least an O or an N. If it were an N, you would probably also see a broadened NH somewhere in the molecule. If it's an O, you don't see anything else except you would have to see 2 oxygens in the chemical formula for that. Okay? So practice the NMR spectra in the textbook at the end of this chapter. The exam will most likely have a NMR spectrum of some kind of compound like this that you'll have to decipher with the help of IR or chemical formula or mass spec information. So that's it for now.